Dear student, the previous class we are discussing about electroplating process in a metal finishing process. We have studied about the different types of methods and different techniques of electroless plating process. Under that electroplating, now I will take up that electroplating. Now electroplating can be defined as is a process of coating of metal on metal or metal on alloys by using electric current. By the help of electric current, you can easy to plating of metal on metal or metal on alloy. That process is called electroplating. Now, how to do that electroplating process? To do any electroplating process, these are the minimum conditions. These are the minimum requirements to do any electroplating process. Now, plating can be done either on metal or metal on alloy by the help of electric current. That is called electroplating. In electroplating process, anode is important, cathode, the electrodes are required. Anode, cathode, and electrolyte is most important, and current electricity is required. And anodic reaction and cathodic reaction, what happens? Just you can see that. To do any electroplating process, anode, generally the anode, and this is the cathode. Cathode is always object to be plating. Which object you want to plate or plating, that is always connected at cathode, because at cathode reduction reaction takes place, at anode oxidation reaction takes place. Now object, suppose if you connected at anode, is not possible to plating. Which object you want to plating, it is always connected at cathode, because at cathodic region they undergo reduction reaction. All metal ions are converted into metal atom. That layer is coated on the object. Now that is as the one of the important factor. Object always is placed at cathodic region, and anode either may be a pure metal of respective coating metal or may be alloys. But in case of chromium, the alloy is used because the acid electrolyte is used in that. That's why they are going to use the alloy instead of pure metal. In some cases, I want to plating of gold solution to be taken as electrolyte. Now electrolyte is also one of the important factor. The anode either may be a pure metal or may be alloy. In some cases they are used the pure metal. Suppose I want to plating of gold rod is used as anode, and is in a copper plating process, copper rod, the pure copper rod is used as anode. Object which one you want to plating, that is always connected at cathode. By applying electric current, the oxidation and reduction reaction takes place. Now oxidation takes place at anode, reduction takes place at cathode. Now the electrolyte, what type of electrolyte you have to take? The electrolyte is a soluble salt solution of coating metal. I want to plating of copper sulfate solution taken as electrolyte. Then if you salt copper sulfate is dissolved in water, it ionizes copper 2 plus and sulfate 2 minus. Now that ions are available in the electrolyte, that metal ions. Now I want to plating of gold chloride solution taken as electrolyte. Now gold, when dissolve that gold chloride in water, it ionizes gold ion and chloride ion. Now gold ions, that is a metal ions, are available in the electrolyte. Likewise, soluble salt solution of coating metal. Which metal you want to coating, that metal salt solution taken as electrolyte. I want to copper plating, copper sulfate should be taken as electrolyte. I want to plating of gold solution is a electrolyte. Likewise, now electrolyte is a soluble salt solution of coating metal. Which metal you want to coating, that metal salt solution taking of solution is taken as electrolyte. These are the important points. Now these are the minimum conditions. Then there are electric current. This is a direct current they can use, apply the electricity between anode and cathode, that reaction carried out. Now at anode oxidation reaction takes place. At anode oxidation reaction, the metal ions when dissolved that, they ionizes Mn2 plus and N electrons. Now metal ions present in that, electrons there. Then at cathodic reaction, now when apply the electric field between the two electrodes, the oxidation takes place, electrons are transferred to anode to cathode and get reduction takes place at cathode. These metal ions present in the electrolyte, they are all migrated towards cathode and get reduction at cathodic region by gaining of electron, it convert into metal atom. Now for example, now you are taken that copper ions present in that, when apply the electric field, when they undergo oxidation and reduction reaction. Now this is an oxidation reaction and this is a reduction reaction. Metal ions present in that, the electrons transfer from anode to cathode by gaining of electrons. This is undergo reduction at cathodic region, they convert into metal ion into metal atom layer. Now this copper coated on the surface of the object. Suppose this is an object, now object is coated by the respective salt, metal layer. Now that is coated on the surface of that. That is process called electroplating. Electroplating can be carried out by using electric current. Metal can be coated on metal or metal can be coated on alloys. These are the conditions. Okay. Now this is about electroplating process. Now what is meant by electroplating? Electroplating is the process of coating of metal on metal or metal on alloy by using electric current. That process is called electroplating. Then you come to that electroplating of chromium, either maybe hard chromium or decorative chromium. Now just you can find out the differences between the electroplating method of chromium hard and chromium decorative. Now electroplating process, these are the composition. Now these are the conditions and compositions are required, plating both conditions like that. In any electroplating process, path decomposition, that is an electrolyte is important, electrolyte, then temperature. To get a good deposition, always you have to maintain the suitable temperature, moderate temperature and moderate current density. Now suitable temperature and pH and also current density, you have to low current density is always a favorable good condition to get a good deposition. Low current density is most favorable condition to get good deposition on the metal on metal or metal on alloy during electroplating process. Now you can see that electroplating of chromium, hard chromium and decorative chromium, there is a difference is almost same. Now only 1 or 2 is the difference and reaction is different. Just you can see that to get a hard chromium and to get a decorative chromium process. Now this is the plating bath solution. Bath composition is hard chromium, they are taking chromic acid plus sulfuric acid 100:1 ratio. The same composition in also decorative chromium, chromic acid plus sulfuric acid 100:1 ratio, and temperature should be maintained to get a good deposition. Suppose if you apply high current temperature, then at high temperature decomposition is more. Therefore, you have to use the suitable or moderate temperature during electroplating process. For hard chromium process also required 45 to 55, that is the range. Above room temperature is a good condition to get a good deposition, the temperature. Now generally most of the metal can be plated within 30 to 60 degree temperature, above room temperature even up to 60 degree, that is the range. It is the optimum range of temperature to get a good deposition during electroplating process. Now for this case, the hard chromium they required 45 to 55 degrees centigrade, and as well as decorative chromium also they required the same temperature 45 to 55. Then you come to the pH. What is meant by pH? pH can be defined as, that is a negative log of base 10 hydrogen ion concentration, that is called pH. pH can be defined as negative log of base 10 hydrogen ion concentration. On the base of that pH, we are divided into acid, base and neutral solutions. The pH range is 0 to 14, 0 to 7, exact 7 is neutral, less than 0 to 7 is an acidic, 7 to 40 is an base. Now pH is also one of the important factor during electroplating process. Now if you use the acidic condition or basic condition, to get a hard chromium and decorative chromium, the pH range is 2 to 4 pH. 2 to 4 is an acidic. Now in the acidic condition, the good deposition takes place, that is at 2 to 4, and here also they required 2 to 4 pH. Now temperature, pH and composition almost similar either in the hard chromium process or decorative chromium process. Then I come to the current density. Current density can be defined as current per unit area of the electrode surface. Current per unit area of the electrode surface, that is the current density. Now suppose if you apply the high current density, what happens? You get a good deposition or not? You should know that if you apply low current density, which is the most favorable condition during electroplating process. Now during electroplating process, suppose if you apply high current density, when apply the high current density, the reaction is fast. At anodic reaction, at cathodic reaction, the reaction is very fast, electron transfer is very fast, and diffusion on the surface of the object is slow. Then it become not get a good deposition, it become brittle and loose deposition. If you are applied high current density, the good deposition is not possible to get on the surface of the object. You get loose and brittle deposition. Because of that reason, electron transferring is fast, diffusion on the surface of the object is slow. Electron diffusion takes place on the surface, that is slow compared to electron transfer. Therefore, it become loose and brittle deposition. Therefore, low current density is a favorable condition to get a good deposition. You have to apply very less current density, then what happens? Electron transfer is very less or very slow, then diffusion is fast. Therefore, it become good deposition or firm deposition takes place on the surface of the object when apply the electric field. Therefore, finally, what is that? The current density is always low current density is the favorable condition to get a good deposition. Now, in this case, hard chromium process, the current is applied 290 to 580 milliampere per centimeter square. Not ampere is required, only the low current density, milliampere. So, 290 to 580, this is required, is still less in the decorative chromium process 145 to 4. That is the range, the minimum 290 and above, and less than 580 milliampere per centimeter square. Here is required 145 to 430, less than that the milliampere current is enough to get a good deposition. I think all of you understand that current density, low current density is the favorable condition. If you apply high current density, diffusion is fast, electron transfer is fast, diffusion is slow, then it become brittle and loose deposition. If you apply low current density, electron transfer is less, diffusion is fast, then it become firm deposition or good deposition takes place. In this way, can easy to plating of metal on metal or metal on alloys by using these conditions. Then you come to the anode. Now generally anode, now in the case of chromium plating process, because you are using both are acids, the both composition containing chromic acid as well as sulfuric acid. Now these two, if you use that pure metal of chromium in this case electroplating process, they reacted, it undergo decomposition. To avoid that, generally in chromium plating process, in some other metal they are going to use the pure metal, but in case of chromium the anode is always alloy, either may be tin and lead and tin alloy, either may be lead and antimony, antimony means SB, antimony, symbol is SB, lead and antimony alloy coated with lead dioxide. These kind of either may be stainless steel, these kind of anodes they are used in the case of chromium plating process, either may be hard or decorative chromium coating process. They are going to use the anode is alloy, lead and tin or lead and antimony is coated with the lead dioxide. Then you come to the cathode. Now the cathode generally they have used the object, pre-coated object. Pre-coated means suppose if your object containing any oil and greasy layer, that should be cleaned by using organic solvent. That should be treated with organic solvent. Before electroplating, the object should be cleaned, that is called pre-treated. Pre-treated means if containing any rust or any oxide layer on the surface of the object, that should be cleaned properly. If containing any oil and greasy layer, that should be cleaned properly. How to do that? To remove the oil and greasy layer, the object should be washed with organic solvents. When you wash with organic solvent, that will remove the organic matter. Suppose it containing any oxide layer, already the paint is there on the surface, that should be cleaned properly by treated with dilute sulfuric acid. And then that article is ready, the object is ready, that is called pre-treated object. Before electroplating, the object should be cleaned properly, if depends on impurity present on that. That is cathode, object to be plated is always connected at cathode. Instead of cathode, if you connected anode, it is not possible to get the plating. Now, because at cathode only reduction reaction takes place, metal ions gaining of electron convert into metal atom. That layer is coated on the surface of the object. Therefore, the cathode should be pre-treated object. Here also pre-treated object. Then current efficiency by applying electricity, already where apply the electricity is very low, then it becomes 17 to 21% current efficiency. In case of decorative also 10 to 15%. Then come to the applications. Now high hardness and corrosion resistance can be get by hard chromium plating process. Under this reaction conditions, now if you apply the electricity, they undergo electroplating of chromium on the surface, you get high hardness. There is a hardness is increased and also corrosion resistance can increases. That is a main application in the hard chromium process. But in decorative chromium process, very brightness. Now highly illuminate is high and brightness and decorative look. To get a bright and decorative look, you have to apply for decorative chromium process. Now that are the conditions. Then you come to the finally the reactions. Now reactions is now chromic acid, chromic trichromic oxide, chromic trioxide is react with water, it convert into chromic acid. Now this chromic acid equilibrium with the dichromate and it gives CH2 Cr2O7 plus H2O. That is the chemical reaction takes place and deposition takes place in case of hard chromium. In the decorative chromium, that is the reactions H2Cr2O4 that is undergo that's H2Cr2O7 plus H2O, and this is the reversible reaction. This undergo reduction reaction is converted into chromium. Chromium is plated on the surface in this reaction. 14 H plus and 12 electrons, they undergo gaining of electrons, reduction reaction. The chromium ions are plated on the surface of object. In this way, electroplating of chromium either may be hard or decorative. Chromium can be plated by using this condition. Now, this generally they concentrate on electroplating methods. Next, I will go for the electroless plating process. Electroless plating process. Now, electroless plating means electroless plating, you should know the differences between electroplating and electroless plating. Electroplating, by using electricity, you can easy to plating of metal on metal or metal on alloys. Now in the electroless plating, without using electric current, the plating can be carried out by using suitable reducing agent. By the help of suitable reducing agent, without using electricity, you can easy to plating of metal on metal, metal on alloys, metal on semiconductors, metal on insulators, even metal on ceramic compounds. Compared to electroplating, electroless plating has wide application. Okay. Now electroless plating can be defined as it is a process of coating of metal on metal or metal on alloy, metal on semiconductor or metal on insulator without using electricity by the help of suitable reducing agent on the catalytic active surface. That is called electroless plating. Now, how can you achieve this electroless plating process? Now, the electrolyte containing metal ions, either for electroplating process or electroless plating process, the electrolyte is same. I want to plating of copper sulfate solution taken as electrolyte. Either you can done by electric plating method or electroless plating process. Now, in both the cases they required electrolyte. The electrolyte always containing metal ions. Suppose you take the copper sulfate dissolved in water, it ionizes that containing metal ion. Or you take in gold solution, they are dissolved in water, gold ions present in that. Now, any salt solution containing metal ions, that is an electrolyte. The electrolyte containing metal ions, and they are going to use the suitable reducing agent. Now, suitable reducing agent, if you use, that itself act as oxidizing agent, this is reducing, again undergo autocatalytic redox reaction. But in the electroplating process, the oxidation takes place at different place, reduction takes place at different place. But oxidation at anodic region, reduction at cathodic region. But in case of electroless plating process, both redox reaction, autocatalytic redox reactions takes place on the same surface or same surface of the object in the catalytic active surface. Now, how you can activate the surface? By using, there are three different technique. Now, activation of surface is important in electroless plating process. Now, here taken the electrolyte, they containing metal ions and they are going to use the suitable reducing agent. the suitable reducing agent, it reduces metal ion into metal atom. Now reducing agent reduces metal ion into metal atom, that is they coated on the surface of the object without using electricity by the help of reducing agent. Now this act as oxidizing agent, oxidizes and gives oxidized product. Now that is the chemical reaction. Autocatalytic redox reaction takes place in electrolysis plating process. In this case, activation of the surface, object surface should be activated, either may be metal or may be non-metals or alloys or semiconductors or ceramic compound or insulators. Now they required some metal surface required activation. Now activation can be done. The activate the surface of the object can be carried out by 3 different techniques. For example, some metals, the surface of the metal, they can be activated by treated with acid treatment. Just to take the object, they immersed in the acid, that surface become more active. That is called acid treatment. The object should be treated with acid, the surface become more active, then is subjected to electrolysis plating process. Then some metals just heat the surface. Now rub the surface by using a wire brush, that become heat up, that become active. Some metals heat treatment is required to activate the surface. But in the third method, stannous chloride palladium chloride solution treatment, that is only applied for insulating materials, semiconductors and ceramic compounds. Now that surface can be activated by using stannous chloride and palladium chloride mixture. Now this solution mixture is treated on the surface of the object, either in the insulator to activate or semiconductor to activate. Stannous chloride palladium chloride is more important. Now this solution you have treated with that, the surface become more active, then only they are subjected to electrolysis plating process. Now these are the 3 different techniques to activate the surface, either by treated with acid treatment or by treated with heat treatment, or for insulator and semiconductors you should treated with stannous chloride and palladium chloride solution, SnCl2 PdCl2, stannous chloride palladium chloride treatment. This is applied for insulators, semiconductors and ceramic compounds to activate. Now by using this technique, activate the surface and they undergo chemical reaction without using electric current. By the help of suitable reducing agent, it is easy to plating of metal on metal or metal on insulator or metal on semiconductor. That process is called electrolysis plating. Now under that electrolysis plating, you should concentrate on electrolysis plating of copper on printed circuit boards. Now how can you prepare the printed circuit board without using electricity? Now printed circuit board without that PCB board now depends on the size they are decided on the basis of their application, either for watch that is a different size, or calculator or mobiles or TV or laptop, whatever it is, any electronic goods, they are prepared that a printed circuit board depends on the application. Now the printed circuit board can be prepared by coating of copper. Now the insulating material, actually they are taken this suitable size of plastic material to prepare the printed circuit board. Now on that surface, first they are treated with stannous chloride palladium chloride solution before subjected to electrolysis plating of copper on PCB board. Now before that, that surface, the material, the raw material, the plastic sheet depends on the application, size is decided, and that should be activated by treated with stannous chloride and palladium chloride solution, because it is an insulating material that should be activated by immersed in stannous chloride and palladium chloride solution. After immerse that, and by using a suitable marker pen, they draw the circuit diagram, depends on application, whatever they want, they have draw the circuit diagram on that surface. By using a suitable marker pen, first they activate by treating with this, and then by using suitable marker pen containing some chemical, that draw the circuit diagram. After that, they taken this composition. To electrolysis plating of copper, coating can be done on the surface of that, they can be carried out by using this composition. Electrolyte, stabilizing agent, reducing agent, then base, complexing agent, these all things required during electrolysis plating process. But in electroplating only anode, cathode, current and electrolyte. But here electrolyte is same, either in electroplating method or electrolysis plating method, electrolyte is required, respective coating metal salt solution. Here also they required This is a typical composition. 12 grams of copper sulfate salt is taken as an electrolyte. They are dissolved in water. And stabilizing agent. Why they are used that stabilizing agent? Stabilizing agent is required to avoid the decomposition of the plating bath. They are taking different chemicals in the same container, it may undergo decomposition. To avoid the decomposition, they are going to use stabilizing agent. What is the stabilizing agent? This is a good stabilizing agent is the Rochelle salt. Rochelle salt is the common name. Before IUPAC name, there is a common name like copper sulfate, is there a blue vitriol, green vitriol, FES, Mohr salt is a common salt, there is a common name like that. This Rochelle salt is a common name. Chemical name is sodium potassium tartrate. Sodium potassium tartrate, that is a chemical that is generally they are used as a stabilizing agent in case of electrolysis plating process. Now reducing agent is a formaldehyde. Formaldehyde or sodium hypophosphite, these are all the best reducing agent, but in this case electroplating of copper on printed circuit boards, they are used that 8 grams of formaldehyde, 14 grams of Rochelle salt, 12 grams of copper sulfate as a electrolyte, and base is required because the pH is maintained about 11, the base 15 grams of sodium hydroxide, and to get a good deposition, complexing agents are required. This is a 5 grams of EDTA, ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid is the best complexing agent. That's why they are going to use that 5 grams in this process. Now these are the typical amount of substance required to do electrolysis plating of copper can be quoted on printed circuit boards. Now earlier they are taken, activated and draw the circuit diagram by using a suitable marker pen. After that they are taken this composition in the container, they are immersed inside. They undergo chemical reaction. Under this condition, at 25 degree room temperature and pH is about 11, the reaction is carried out. Under this reaction conditions, the reaction is like that. Now the reaction is copper ions present in the electrolyte, they undergo reduction by gaining of electron convert into copper atom that will be coated on the surface. Now in the oxidation reduction, autocatalytic redox reaction takes place here. In the electroplating also redox reaction, reduction at a cathodic region, oxidation at anodic region, but here both reaction takes place on the same surface of the object, activated surface of the object. Now is in 25 degree centigrade at pH 11, that reaction is carried out. Now copper 2 plus ion gaining of electron converted into copper, and formaldehyde. Now formaldehyde is a reducing agent, it reduces copper into copper iron. This is itself act as oxidizing agent, that is converted into formaldehyde into formate ion. Now formaldehyde in presence of sodium hydroxide base hydroxyl ions are available, and that is reaction takes place, it gives formate ion. Formaldehyde converted into formate ion, water and H2 gas plus electrons. Now 2 electron 2 cancel, then you can write the net cell reaction Cu2 plus 2 molecules of formaldehyde HCHO aldehyde group, formaldehyde plus 4 molecules of hydroxyl ions, that will gives copper ion metal atom is coated on the surface of the object, and 2HCOO acetate ion formate ion plus 2H2O hydrogen gas is expels out. That is the net cell reaction. Now you see that formaldehyde act as reducing agent, this itself act as oxidizing agent. Now reducing agent reduces copper ion into copper atom, oxidizing agent oxidizes formaldehyde into formate ion. That is, in this way oxidation reduction takes place on the surface of the object. They are coated with copper metal. Copper is coated complete surface, that is a complete surface of the object is coated. You will not get the desired pattern, but after reaction is carried out, they are immersed inside, the whole surface is coated with copper. Then to get a desired pattern or to get a printed circuit board, that is subjected to photoresist technique. Photoresist technique. They are subjected to photoresist technique. The unreacted, now here draw the circuit diagram by using a suitable marker pen, that is undissolved Now you get a desired pattern, and other area is dissolved in this photoresist technique. Now that is the dissolved, the coated copper is dissolved, and desired pattern is left out. In this way, electroless plating of copper can be carried out by using reducing agent without using electricity. That is the method, electroless plating of copper on PCB. This is the composition, this is the condition. Under this reaction condition, that is a chemical reaction takes place, that will be coated on that surface, you get a copper coating. The insulating material after coated with copper, it become good conductor. That is generally they are used in the printed circuit boards in the different applications. That is about electroless plating of copper on PCB. Next you come to that electroless plating of nickel. Electroless plating of nickel on aluminum, any metal on metal, this on metal on insulator. That is the difference, metal on metal and metal on insulators. Now here in this case, electrolyte 20 grams of nickel chloride solution, and reducing agent 20 grams of sodium hypophosphate, and complexing agent is 15 grams of sodium succinate, and buffer to maintain the pH 4.5, they are going to use the acidic buffer 10 grams of sodium acetate. Now under temperature 93 degrees centigrade and pH 4.5, to maintain the constant temperature, they are going to use the buffer, and to get a good deposition, complexing agent. The initiate the reaction, it is reducing agent, and generally electrolyte, the metal ions are required, the electrolyte is taken. A plating of nickel chloride solution taken, the nickel ions present in the electrolyte, by using a suitable reducing agent, the reaction is carried out under this reaction conditions. In this case, nickel ions present in the electrolyte, the gaining of electron takes place in oxidation reduction reaction, they convert into nickel metal layer, that is coated on the surface of metal, metal on metal, nickel can be coated on any metals. Now reducing agent sodium hypophosphite, that is an H2PO2 minus phosphite, in presence of water they undergo, this is reducing agent always undergo oxidation, oxidizing agent undergo reduction. Now this is a reducing agent undergo oxidation in presence of water, it convert into phosphite, phosphite changes to phosphate, hypophosphite changes to hypophosphate. Now hypophosphate plus 2 H ions and electrons. Now you can cut out these electrons, okay, these 2 electrons. Then you can write that natural shell reaction, nickel 2 plus ions, they react with sodium hypophosphite H2PO2 minus plus H2O, that will gives nickel plus H2PO3 minus plus 2H plus. Okay. Now this is act as reducing agent, and this itself act as oxidizing agent. Now reducing agent reduces nickel ion into nickel atom, that layer is coated on this object. That is oxidizing agent oxidizes hypophosphite to hypophosphate, phosphate changes to phosphate. This way you can easy to plating of metal on metal or metal on insulator without using electric current by the help of suitable reducing agent. That is about electroless plating of copper on PCB and electroless plating of copper or nickel. Then just remaining, there is a distinguish between electroplating and electroless plating. Electroplating and electroless plating. Now distinguish between electroplating and electroless plating. This is an electroplating and then electroless plating. Now just you can understand that electroplating method and electroless plating method. Now just to distinguish, there are some points you have to mention that distinguish between electroplating and electroless plating. Electroplating process driving force is electricity. Driving force is electricity. Electricity is required to electroplating process. But what about in electroless plating process? In electroless plating process, we are not applying the electricity, but auto-catalytic redox reaction takes place. Automatically, we are using reducing agent, automatically they undergo reduction, because oxidation reduction is a simultaneous process. Auto-catalytic redox reaction, auto-catalytic redox reaction takes place. Now in the electroplating process, electrodes are required. Now anode, cathode, all electrodes and electric connections are required in electroplating process. Here in the electrolysis plating process, not required electrodes or electric connections. But what is required in electrolysis plating? Reducing agent is essential. Reducing agent is required. But in electroplating process, reducing agent is not required. Here electrolysis plating process, reducing agent is initiate the reaction. Now reducing agent is essential, but in electroplating is not required reducing agent. In this case, oxidation takes place at anode, reduction takes place on cathode. There is an oxidation and reduction reaction takes place in electroplating as well as electrolysis plating, but that is takes place in the different places in electroplating process. Oxidation takes place at anodic region, reduction takes place at cathodic region. But in this case, redox reaction takes place on the same surface of the substrate. Now same place they undergo autocatalytic redox reaction. Now that should be a good conductor, otherwise it is not possible to plating in electroplating process. Good conductor. Here either may be a conductor, it can easy to plating, either may be semiconductors or may be a insulators or may be a ceramic compounds. Can easy to plating without using electricity either on conductors or on semiconductors or on insulators and ceramic compounds. But in electroplating process, the object should be a good conductor. Likewise, you can distinguish electroplating and electrolysis plating methods. Now, these are the different points to distinguish the electroplating and electrolysis plating. That is about electrolysis plating of copper and electrolysis plating of nickel. Now, that is about electroplating and electrolysis plating process. Okay.